Have you ever wondered how your favorite online game keeps thousands of players in sync? Or how a bank makes sure every single transaction is perfect? Well, it's a lot more chaotic than you think. Today, we're diving into something called the atomic kernel, a really fascinating system that was designed from the ground up to chase one of the biggest goals in computing: perfect, verifiable mathematical truth. This quote from the source material, man, it just nails it. In pretty much any networked system, there's this constant battle happening under the hood to keep everything in agreement. It's like a low-level hum of chaos that's just always there. And the root of all this chaos? It's time. Yeah, time itself. Okay, picture this. You have a dozen musicians, and you need them to play a song in perfect time. But here's the catch. They're all in separate soundproof rooms. They can't hear each other at all. All they have are their own clocks, which are all ticking at slightly different speeds. That, right there, is basically what our computers are doing every single second of every day. And what's really wild is the physical reality behind this. The tiny quartz crystal on your computer's motherboard, it literally vibrates at a different speed depending on how hot it is. It's like a tiny temperature-sensitive metronome. Now, you add to that the fact that data packets just get lost all the time as they zip across the internet, and you end up with a digital world that's built on a foundation of guesswork. So yeah, this slide really lays out the two sides of the coin. On one hand, you've got the messy, unpredictable physical world that we've all just kind of accepted. And on the other, the atomic kernel comes in with this radical alternative, a perfect, purely mathematical software crystal that never ever drifts. So how in the world does this software crystal even work? Well, at the very core of the atomic kernel is this tiny foundational script called crystal.py. And this isn't a program like you're used to thinking of. It's more like an immortal digital metronome. And here's the key thing to understand. The crystal's only job is to provide a perfect, unyielding heartbeat for the entire system. It doesn't run logic, it doesn't make decisions, it just ticks with this unwavering precision, whether anyone is listening to it or not. Okay, so where does this perfect rhythm come from? It all starts with the surprisingly simple fraction, 1 divided by 73. But the reason behind this specific number, that's where the real beauty of the system starts to show. This is so cool. It's a perfect example of how the design of this whole thing is dictated by the laws of mathematics itself. See, the system's architecture needed an 8-step oscillation for a full cycle. And it just so happens that the smallest prime number whose repeating decimal sequence is exactly 8 digits long is 73. It wasn't a choice. The math itself forced their hand. So the system takes that 8-digit sequence from 1/73 and uses it as its rhythm. Then it uses this special mixing constant that acts like a mathematical whisk, scrambling the bits every single tick. This keeps the system from getting stuck in some boring, simple loop. And what you get is a heartbeat that is both perfectly predictable and infinitely complex. All right, now that we have a perfect clock, we can finally start building a world on top of it. And the very first thing we're going to do, and this is going to sound nuts, is get rid of memory. That's right, a world with no memory at all. So in this system, you have these things called observers, which are just pieces of code that read the crystal's pulse. Each observer gets a unique seed, which is just a starting number that defines it. You can think of it like a unique DNA sequence for every object in the world. And the combination of its personal seed and the crystal's current tick, that determines every single thing about that object. And here it is. This is the most counterintuitive and honestly the most brilliant part of the whole design. The system does not remember where an object was a millisecond ago. Not at all. It computes the entire universe from scratch every single frame, based only on the object's seed and the current time on the clock. So right about now, you're probably asking the obvious question, right? If you're recalculating everything from zero every single time, how do you get any kind of continuity? Wouldn't the world just be a bunch of random, flickering flashes? And the source material gives us this absolutely perfect analogy, a kaleidoscope. Think about it. The continuity we see isn't because the system is remembering the past. It comes from the unbreakable mathematical laws that connect the seeds to the crystal's perfect progression. The math is continuous, so what you see is continuous. So why on earth would you go to all this trouble? Because it completely, utterly eliminates an entire class of bugs. You know when a video game character glitches and gets stuck inside a wall? That happens because two different parts of the game got out of sync. They disagreed on where the character was. That's a memory error. In a world with no memory, those bugs are literally impossible.
But, of course, creating a memoryless world introduces a brand new, massive problem. If the universe forgets you exist every single frame, how do you prove who you are? What stops someone else from just pretending to be you?
The solution is to lean into something even stronger than memory: strict cryptographic proof. The system uses what are called deterministic hashes. You can think of them as unique, unforgeable digital fingerprints to establish identity and basically enforce law and order in this universe. And here's how it works. An object's identity isn't just a name, it's a cryptographic chain. Each new object ID is a hash of the current time, the object's unique properties, and, this is the crucial part, the ID from the previous frame. This creates an unbreakable chain of proof that stretches all the way back to the object's creation. It's like a digital paper trail that is impossible to forge. Okay, this all sounds fantastic in theory, but how do you actually prove it? How do you verify that this perfect, deterministic universe is, well, truly perfect? This brings us to probably the most striking part of the whole project. To prove its own truth, the system set this incredibly high bar for itself. It forces two programming languages that are philosophical opposites: Python, the flexible, free-flowing poet, and Haskell, the rigid, unforgiving accountant, to run the exact same simulation and produce the exact same output, bit for bit. The system then packs all of this proof into these incredibly dense Aztec barcodes. Now, when you see this, your first thought is probably what mine was. Okay, cool, that's a link I can scan to download the proof. But that's not what's going on here. Not even close. This is the big reveal. This isn't a link to the data. The barcode is the data. These Aztec codes can store raw binary information right in their pixels. The actual algorithms, the mathematical rules, the entire universe is compressed directly into this image. It's a self-contained, verifiable universe. In a picture. So let's just quickly recap this wild ride. We started with a perfect software crystal to replace messy physical clocks. Then we built a memoryless world on top of it to kill an entire class of bugs. We added cryptographic laws to create unbreakable identity. And finally, the whole proof of this universe got packed into a scannable barcode. This whole project really forces you to ask a pretty profound question. We spend so much of our time just trusting that our software works, hoping that our data is in sync, but the atomic kernel shows us that maybe there's another way. It makes you wonder, what if we stopped trusting and started proving? What could we build on a foundation of pure, verifiable truth?